Hey guys, it's time for the summer classes now. We're starting our ON level sessions. We're starting our SAT and GRE sessions. We're starting our university entrance test sessions. They're very vital. Utilize your summers properly. You're getting your university admission exams very soon. You'll be preparing for them. So we have started our university entrance test exams as well. And if you're up for German classes, we have those as well. And if you're up for metric and FAC classes as well, we are interested. We're offering teachers for those as well. And I'll be posting a demo lesson right after this video, so you can check out the quality of lectures that we are offering. And also this time around, we're also offering a very rigorous assignment and testing mechanism where you will be getting weekly reports highlighting your weaknesses and your strengths. And that way, with regular feedback, you'll be able to improve your areas, and the teacher would be able to get to know exactly which areas to focus on, which areas not to focus on. Now, just as a demo, I'm going to try and solve this past paper question. It's a moles past paper question, and it says that compound J burns in excess of oxygen to give carbon dioxide and water only. And when a 3 gram sample of compound J burns in excess of oxygen, 3.4 grams of carbon dioxide and 1.8 grams of water are formed. So here's your basic equation: J burning, producing oxygen and carbon dioxide and H2O. And it's 4.4 grams of carbon dioxide and 1.8 grams of H2O. Now, we've been asked to find or figure out the empirical formula of J. That is the basic task. We need to figure out how many carbons and how many hydrogens, and if there are any oxygens present. The only elements that are present in the products are carbon, hydrogen, and oxygen. So, what I'm going to do now is I am going to assume that the carbon is coming all from J. J has all the carbons. All the carbons that you see over here in the products are coming from J because the oxygen doesn't have any carbons. All the hydrogen that is coming is also coming from J. And the oxygen that is present over here, it is probably coming from oxygen over here, but there might be some oxygen that would be present in J as well, but we're not sure about what amount of oxygen is present in J. So I'm going to try and figure out first the mass of carbon over here. I just need to figure out the percentage since I have carbon dioxide. I know carbon dioxide is 44, the MR is 44, that's one carbon, that's 12, plus there are two oxygens, that's 16 plus 16. So out of this 44, there's only one carbon, so it's 12 over 44, that's the percentage, fractional percentage of carbon. And I'm going to multiply it by 4.40, and I'll get the mass of carbon this way. And the value that I get is 1.2 grams of carbon. So I found the percentage of carbon over here, and all this carbon is coming from J over here. So J contains, I now know it contains exactly 1.2 grams of carbon. And in a similar way, I can figure out the amount or mass of hydrogen that is present in this molecule over here in water. So you've got water, which has a mass MR of 18. That's 1 plus 1. That's hydrogen is 1. And you have oxygen, which is 16. So 1 plus 1 plus 16, that's 18. And out of that 18, you've got two hydrogens. So 2 out of 18, and I'm going to multiply it by 1.80 grams. That is the mass of water. And if I do my calculations, so the answer for this I'm getting is 0.2 grams of hydrogen. So all the hydrogen, my assumption is that all the hydrogen is coming from J. It's not an assumption, it's a fact actually, because oxygen doesn't have any hydrogen. So all the hydrogen that you see in the products is actually coming from J over here. So so this one is 0.2 grams of H. And there was something that was given in the question, and that was the total mass of compound J over here, which is given as 3 grams. So if you look over here, you would notice that carbon is 1.2 grams, hydrogen is 0.2 grams. This sums up and it totals up to be 1.4 grams. So there's still 1.6 grams that's missing. And that 1.6 grams must be the oxygen, because that's the only third element that's present in the product. So So the missing mass must be coming from oxygen. So compound J contains oxygen. That's a fact now, and the amount of mass is 1.6 grams because all of this should add up to it should add up to 3 grams. Now, the next part is fairly easy because once you have the individual masses, you can just figure out the empirical formula, find the moles of carbon. So I'm going to divide by the AR, find the moles of hydrogen, I'm going to divide it by its AR, and I'm going to find the moles of oxygen, I'm going to divide it by its AR, which is 16. So I found zero point 0.1 moles of carbon, zero point 0.2 moles of hydrogen, and zero point 0.1 moles of oxygen. And since we are looking for the empirical formula, which is the simplest whole number ratio, that's fairly obvious. It's 1 ratio 2 ratio 1. So that means we've got one carbon, we've got two hydrogens, the ratio is two hydrogens, and we've got one oxygen. So it's C1, H2, and O1. That's the ratio that we are getting, and that's our answer, which is going to be option D in this case.